Suppose we're asked to find the domain and the range of a function. Well, in order to do that, we need to understand what the domain is and what the range is. So let's consider the domain. The domain is defined as the set of all possible input values for a function. All possible input values. Another way of saying this is all possible x values that we could input into an equation for that equation to remain valid. Let's consider the equation y equals x squared as an example. So to find the domain, we need to consider all the possible values of x that we could substitute into this equation. For example, let's draw up a quick table of values here of x values and corresponding y values that we could substitute into this equation. Let's consider what happens when we input -2. Do we get some y value? Well, at x equals -2, y equals -2 squared. That's the same as saying -2 times -2, which is the same as 4. So we get some valid value for y when we input -2, x equals -2 into this equation. Consequently, x equals -2, this is part of the domain because it is one possible input value. What about x equals -1? Well, x equals -1, y equals -1 squared. In other words, -1 times -1. And this just equals 1. So consequently, we know that -1 is also part of the domain. It is a possible input value. When we input it into this equation, we get a valid y value. What about x equals 0? Well, at x equals 0, y equals 0 squared. This equals 0 times 0. This simply equals 0. So 0 is also in the domain. It is one possible input value. Let's do one more. Let's examine what happens when x equals 1. At x equals 1, y equals 1 squared, and that equals 1 times 1, and that equals 1. So again, we've got a valid y value here for x equals 1, so 1 is part of the domain. In fact, if you were to substitute any x value that is part of the real number line, that is to say, any x value defined on this x-axis, you would get a valid y value. The way we write this is that the domain of this function is equal to all real values of x. Values of x. And you'll also see this written as all real x. They're exactly the same statements. This is just a shorthand version. Let's consider what this statement means graphically. Well, if we were to draw the graph of the function y equals x squared, we would get a graph that looks like this. Y equals x squared. What this means is any value on this x-axis that we input, for instance this value here, we will get a corresponding y value. Doesn't matter which one we input, we could input one anywhere along this x-axis, and we would always get a corresponding y value. And consequently, the domain is all real numbers defined by this real number line. Okay, well let's consider the range. So the range of a function is defined as the set of all possible output values. All possible output values for a function. Another way of saying this is all possible y values. So when we input x values, the y values are the output values. Let's consider this table that we constructed before in order to discover the range of this function. Here, for the input x equals -2, we had the output y equals 4. For the input x equals -1, we received the output y equals 1. For the input x equals 0, we had the output y equals 0. And for the input x equals 1, we had the output y equals 1. Each of these is either positive or 0. At no point did we get a negative output of y. In fact, this function is defined such that for any value of x that we input into this equation, we will always get a positive value of y. And that's because x squared is always positive for any real input. So the range of this function is the set of all real values of y greater than or equal to 0. And the way we write that is y greater than or equal to 0. What this means graphically is that any point we choose on this graph will have a positive y-coordinate associated with it. And there will be no point that has a negative y-coordinate associated with it. In other words, none of this graph appears below the x-axis. It all appears above the x-axis. So whenever we want to find the domain and a range of a function, we generally follow these sort of steps. One final note, in some textbooks you might see this expression, y is greater than or equal to 0, written in this way. Y is greater than or equal to 0. These squiggly things are called braces, and this is a colon. So the braces indicate that there is some set here. This is what the textbook authors mean when they have these braces. So literally, we'd read this as the set defined by whatever is inside these braces. And this colon, we can read this as such that. So this means the set of all y such that y is greater than or equal to 0. Essentially, these are the same expression. These are just different ways of expressing broadly the same notion. That is, this is the set of all y such that y is greater than or equal to 0. Similarly, you might see all real x in these braces, which would mean the set of all real x values. Either way, again, it's exactly the same thing. It just depends on the terminology that your particular textbook is using. So a quick note to look out for this when you're going through your textbook and looking at answers.